This video is going to introduce a lot of new definitions, but I'm hoping that we've kind of talked about many of them, so it won't be as many new definitions as you might think. We're going to talk about cost, revenue, and profit. Okay. So some of these will be new, some of these will be old, but in general, when we talk about the total cost of producing some quantity of items, that total cost is going to be fixed costs and variable costs. That's the only options for costs, right? Something either has to be fixed, unchanging, or variable, it has to change or depend on things. So a lot of times we'll box things into one thing or the other. Fixed costs, that could include startup costs, could include flat fees, could include constants such as equipment, buildings, rent, insurance, which rent and insurance are constant until they're not, until people hike up the rates and so on. Variable costs is what depends on the number of production. Uh, when we talk about variable costs, we're usually going to specifically refer to costs that depend on how many units that we're producing. And those usually include materials, labor, utilities can sometimes be fixed costs, sometimes variable costs, and so on. For example, if we need to have our building open an extra 2 hours to produce extra units, utilities can be thought of as a variable cost in that case. Revenue is not the same as profit. Profit's going to be the difference between income and out. I hate saying that. If profit's going to be the difference between what we're bringing in and the costs that we're doing. Revenue is just what we're bringing in. Okay? Revenue is just what's coming into us. It's not how far we are ahead. So in simple cases, if we're only selling one thing and that's our whole revenue, then the revenue of selling Q items is just going to be, well, how many are we selling and how much money are we making from each thing? Multiply them together. That's one way that we can model revenue. Profit is, different from revenue, and that's just going to be how far we come out ahead. It's how much money we have after we account for costs. So profit will always be just the difference between revenue and cost. Take your revenue, subtract out your costs, that's profit. Okay. Revenue and costs will always be positive. We're never really going to talk about negative revenue or negative costs. Not really. But profit can be positive or negative. Positive profit, you like that as a business. Negative profit, that means your costs are more than your revenue, and that's not so good. The last definition that I want to talk about is the break-even point. So this is the level of production where revenue matches cost. So it breaks even because if the point where revenue matches cost, usually if we're before that, costs are going to be higher. We're in the red. After that break-even point, usually revenue is going to be bigger. We're going to be in the black. Okay? I don't know if people even say that anymore. It's kind of an old thing talking about being in the red. Anyway, so this is I think I said that. It's usually the minimum amount that we need to make a profit. So let's use all these definitions with an example. And we're looking at a tech startup and they're looking to develop and launch a new mobile app. The initial development of the app is going to cost about $300,000. And they estimate that their marketing and support for each user is going to be about 50 cents. While even though the app's going to be free, they are also estimating that they'll be able to bring in about $2 on average per every user who uses this app based on in-app purchases and ad revenue. Using revenue and cost functions, how many users will the company need to break even? There's a lot going on here. Feeling overwhelmed? Go back through the steps of the first video, step 1 through 8. Okay? Let's come up with some variables. We're interested in break even. Okay. That's going to have to do with revenue and cost. Okay. We're going to need to talk about revenue and cost. That's for sure. Okay. So let's let R be revenue in dollars. And let's say C is cost in dollars. And usually usually in this section, we've only dealt with 2 variables. But we're going to need more variables here because revenue depends on something and cost depends on something. They don't necessarily depend on each other here. What else do these depend on? Well, we're bringing in $2 per user. That's some kind of rate of change, maybe a slope. So we're also going to talk about how many users we have. You could have be n number of users or a different variable. Okay, let's start with that. We might need to add another variable. If we find that something's missing, we can do that. So we need to find the revenue and cost functions now, right? What we want is the break-even point. What is the break-even point? I don't remember. Let's scroll up to our definitions. The break-even point is when revenue is the same as cost. Oh, so what we want is when is revenue equal to cost. That's what we're really trying to find for this problem. When is revenue equal to cost? So to do that, we need to find revenue. This is our pathway to get there. That's not an R. We need to find the revenue. We need to find C. Set them equal. That's how we solve this problem. That's our pathway. So let's try to model the revenue. The revenue in general, if we're only selling one thing, and that's our whole income, the revenue is going to be, well, how much revenue do we get per item? And how many items are we selling? Well, we're not really selling because the app's free. But we are bringing in a revenue of $2 for every user of the app. So, you know what they say is if the product is free, then you're the product. So here, you are the product. The revenue is just going to be $2 for every user of that app. Let's gut check, see if that makes sense. This says that if we have nobody using the app, there's no income. Yeah, that makes sense. If we have 10 people using the app, this says we'll have a revenue of $20. Yeah, well, if we're bringing in $2 per user, that checks out. Okay, so just doing these mental checks at a revenue function sounds right. Our cost is a little bit more complicated because our cost does have a fixed cost. There's no fixed revenue in this sense. Maybe if we had some sort of, I don't know, backer or something that was telling us that they're going to give us money for free, I don't know. They'd probably want it back. For costs, we're going to have fixed costs and variable costs. Total cost is going to be the fixed plus the variable. So what is the fixed cost? That's going to be the initial development. All right, initial development was 300K. That's our fixed cost B. What's our variable cost? The variable cost is the cost that depends on how many units we have. And again, our units here are just users. What cost depends on how many users? That's going to be this slope. The cost, and again, you might think, oh yeah, we're losing money per every user for this 50 cents. And that's true, but the costs are going up. We are going to plus 50 cents for every user. And again, you could either write these with variables or you could write these in function notation. R of n, C of n. These would mean the same things. And again, we could gut check. Okay, if we have no users, what are our costs? 300K. That makes sense. We have 10 users. Well, we're having to pay 50 cents for every user for the marketing and support. So that's going to be an extra $5, 300,000, an extra $5. Yep, we're adding them together. Formulas check out. So set them equal, and then we'll basically be done. So C equals R when, wait, hold on, let's be consistent. It doesn't matter. But R equals C when R, which is 2N, equals C, which is 300K, plus 0.5N. Just solve this linear equation. Subtract 0.5N. And then we're going to get 1.5N is equal to 300K. Divide both sides by 1.5. You're going to get N is 200,000. Oof. We need at least 200,000. We'll break even. Wait, break even point as a noun has a dash, but without a noun. We break even at 200,000 users. So I hope our app is popular. Gosh. Maybe that's not a lot, but it sounds like a lot to me. Oh gosh. All right, we double check, make sure our answer makes kind of sense. And yeah, well, if we're making $2 for every user and we're losing 50 cents, well, we're making $1.50 per every user. So to get up to that, to like, you know, make up for all that development cost, 200,000 is going to get 200,000 times 1.5. Yeah, that's 300,000. Our answer makes sense. Graph the revenue and cost functions. So if we do that, we know that the revenue is just 2 times N. And the cost is 300,000 plus 1.5, sorry, plus 0.5 times N. The break-even point is when cost equals revenue. Again, our x-axis, we're going to need to go at least 200,000. And our y-axis is going to start at 300,000, so it's going to be at least 300,000. Go like 350,000. Okay, not quite. We need to zoom out a little bit. You see that here's our revenue. Here's our cost. So for any users in this range, for any inputs in this range, look at the difference between our cost and revenue, right? If we don't have any users, difference between cost and revenue is huge. That's bad. But as soon as we get to this break-even point, the input is 200,000 users. The output is cost and revenue, depending on whether we're on the orange line or the blue line. Here, the cost and revenue will both be 400K. And anything after that point, blue is our cost, blue is our revenue, will be bigger as an output than our cost as an output. All right, so you can visually see that break-even point. Say over here, this is not a good place to be. Over here, that is a good place to be. All right, let me know if you have any questions about this. Part C is going to check our answer for part A. It says find the profit function and use that profit function to find the break-even point. Let's make sure it's a break-even point. So what is profit? I don't remember. That's a lie. I do remember. But if you didn't remember, profit is revenue minus costs. So profit is equal to revenue minus cost. What is revenue? 2N. What is cost? 300,000 plus 0.5N. And I've made a tiny mistake here, but a very common one. We need to subtract the whole cost. But currently, we're only subtracting the 300,000. So we need parentheses when we subtract the cost. Always watch out for that. We're subtracting the cost, and the cost is the whole thing. We need to subtract the whole thing. We need to distribute that negative. So our profit is 2N minus 300K minus 0.5N, and now we can collect like terms. We have 2 N's, we're losing half an N. Now we have 1.5 N's. We're still losing 300K. So what did profit have to do with break even? We said the break even point was when revenue was the same as cost. Oh, it's also where profit is 0. It's the same thing. So when is profit equal to 0? And notice that this question is the exact same as this question, because profit's revenue minus cost. If you look at this equation and you subtract cost from both sides, the left will be revenue minus cost, the right will be 0. Revenue minus cost is just profit, so it is profit equaling 0. So that's going to be when 0 equals 1.5n minus 300K. Solve this equation. Add 300K to both sides. That's 1.5n. Divide both sides just like before. And you'll get 200,000 again. Again, break even at 200,000 users. And we can look at this graphically as well. We don't have to. We're done with this. But we could look at it graphically as well. We looked at the profit function, which was 1.5n minus 300K. Then look, to the left of 200K, our profit values are negative. To the right of 200K, our profit values are positive. That just means the same thing. Okay? And if you graphed all three, if you took blue and subtract the orange, you get pink. We're not really going to worry about that part right now, though. There we go. That is all we're doing in this video. Let me know if you have any questions, and have a good one. Bye-bye. If I can hit the stop button.